Hello, I am Helen James. I am curator of birds here in the museum in the Department of Vertebrate Zoology. And I study the evolution and extinction of island birds, but I'm just going to talk about the extinction side of things today. Now, as a girl growing up in Arkansas, I was fascinated by the arrowheads or projectile points in fossils that I saw around me, and I was curious about the evidence that we can dig up about past life. Later, my interest shifted and I became more interested in learning about how people have altered ecosystems. And what was it like to be the first humans to walk in the woods around here, and what has changed? Now, part of this is pure jealousy because, we'd all like to have had that experience. But also, I think there are some important questions for the present because these questions, we all know it's important to establish the baselines, to know what our targets are, or be able to debate what our targets are for ecological restoration. We need to understand extinction risk, and a good way to understand that is not to study what's alive now, but what has actually become extinct recently. And so I show you examples here from our own region, the eastern United States. These are birds painted by John James Audubon from birds that he observed in life or recently dead birds. And this illustrates that there have been changes in bird communities in our region. And some of these birds were super abundant, like the passenger pigeon, and they certainly could have influenced even the composition of the forest in the eastern United States. But if you really want to study extinctions, you ought to go to islands, human era extinctions. Most of the threatened and endangered plants and animals today are on islands, and likewise, most of the mammals and birds that have become extinct, say in the last 500 years, lived on islands. I study the Hawaiian Islands, which we know are a very isolated archipelago, known for their both their wonderful native biota and also for being our nation's hottest of hotspots for the extinction and endangerment of plants and animals now. Now, the Hawaiian Islands also have the advantage for my questions that they were colonized by people very late. In fact, the archaeologists now say probably less than 1,000 years ago. So I don't have to go back tens of thousands of years to study those baselines, and a very recent subfossil record is quite relevant to our questions. The islands are famous for their adaptive radiations of plants and animals, groups of diverse plants and animals that have evolved from a single colonizing species in the islands. And I give you just one example, the Hawaiian honeycreepers. But from our perspective today, the important thing to know about these museum study skins is that most of those birds you see are extinct in that picture, and quite a few of the rest of them are now endangered. So extinction has continued during the human era. But I want to look further back in time, and Storrs Olsen and I, for several decades, developed the fossil record of the islands. And by now, there are over 100 fossil localities, and for the last 5 years with an assistant, Megan Spitzer, we have been building a database of identified bones, which will be a very good resource for studying the relationship, for example, of body size or geographic range to extinction risk, and also for understanding what ecological roles used to be present in different habitats in Hawaii that were missing historically and that we didn't know about to really understand our baselines. So where are fossils found in a recent volcanic archipelago? Well, here are some examples of places. This pretty much covers it. Lava tubes are the plumbing system of lava rivers. When the hot lava drains away, empty pipes are left. And when there are openings to the outside, they can be traps for animals. Very good at preserving bones. And what became extinct? Well, here are some artist depictions of some of the extinct birds. Many flightless terrestrial species ducks, geese, ibises, rails, all with flightless examples, practically all the predatory birds, and a tremendous number of small songbirds or perching birds. So the surprising thing about this extinction is that it not only affected large things, but very many small things in the forest. Now, radiocarbon is an important tool for understanding these extinctions, and I give you two chronologies of radiocarbon dates with a gray bar to indicate when humans probably arrived, and you can see that the distribution for the fossil bird goes right up after human arrival, and for the invasive Pacific rat begins at about the time of human arrival. So let's look at how extinction affected just the biodiversity of birds there. Before these extinctions, there were over 107 endemic species of birds. In the 1880s, only 55 of those could be found by ornithologists, and now only about 11 of those have not made it onto the threatened or endangered lists. And just to be clear, these are the bones that, these are the species that were known only from those bones and were unseen in our assessment of Hawaiian ecosystems. Extinction risk was not shared equally. For example, among feeding guilds, as you see, predators and seed-eating birds and herbivores were big losers. Nectarivores were winners. I end on a text slide just to illustrate that there's a rich theoretical marketplace for explanations of these extinctions. We won't cover them all today, but they don't all fit the Hawaiian situation well, and so part of the problem is to figure out what exactly did happen. And there is a move among some people to blame the invasive Hawaiian Pacific rat for a great deal of this. So now I hope I have time for a question, and I hope also that you will study these heartfelt acknowledgments while you ask the question.
Helen, how does the complex geology work in with construction communities that might differ from island?
Well, there's some very...
Know that each island is its own time frame.
There's the question is, how does the geological basement of the Hawaiian Islands affect the biota? And it affects it very strongly. The oldest islands are to the northwest, the youngest ones to the southeast. And these islands emerge out of the sea, and a whole complex ecosystem forms on them, within about 1 million years and less. So the whole question of evolutionary community assembly is another aspect of this research program that I'm very excited about.